So hi, my name is Hui Yang and I'm going to do the project presentation about a 2D structure solver. Let's suppose that we have a 2D structure like this. It could be a statical indeterminate one, which means that you cannot simply solve it by using the fx, fy, and m equilibrium. If you still want to solve it by hand, there's two ways to do it, such as on the left, the slope deflection method, or on the right, the moment distribution method. But they're like tedious, they're really long, and you can make some mistakes during the process. So suppose if you want to solve it by software, it's also possible. Like for the simple one, there's Reset 2D, or more complicated, like Autodesk Robot or SAP2000. Like, if you download it and you have the license key, it seems that you're all set ready to go. But then you're troubled by the complicated user interface. Like you don't know which button, which key to press to draw the structure on the canvas. So there are also simple way, like there's no fancy complicated operation, and by Python. So this is my project. It's a small program solving the structure by matrix stiffness method, and let's give it a look. So this is the code, and it uses the external package NumPy, and it also uses the internal package Tkinter. So the first part is about the user interface, and then this is the calculation. So I can see that this program supports to solve the 2D structure, which is with or without the settlements, the supports, and also the joint load, the uniform load, and the member loads, which will come up very soon. And then we'll decide the stiffest matrix, and then the forces and the supports are calculated. And then let's test it. So let's use some number to test it, although those numbers will not make any sense in an engineering perspective, but let's just give it a test. So the number of joints is maybe 3, and coordinates, so for the first joint it's be x, y, and the second one x and y, and the third one x and y. And then number of members, because there are 3 joints, so there can only be 2 members. Member information, so the first one is the joint number of the member. The second one is also the other joint number of the member, and then something like the stiffness and the sectional area. Like they're actually a large number, really small numbers, but let's just come up with some random number. And the supports. So there are 2 supports information. Like for the first support, it is fixed at x direction, and it is free at the y direction, and is fixed by moment. And for the third joint, and also it is the second support. Let's try with 1, 0, and 1. And suppose that there's no settlements at supports, and there's no joint load, and there's a uniform distributed load. The direction supposes on the positive x direction, and starting from joint 1 and from joint 2 and end at joint 2, and it's 5 Newton per meter. Although it's not really reasonable in engineering sense, but I just tested and there's no member load. Okay, that's enough. So let's see the answer. The answer is shown here, and you can see the whole process of solving it, including your input, and also like here is starting to determine the P matrix. Is to put all the loads of different members into one matrix, and then the whole process of doing the stiffest matrix, and then finally all the supports. The supports are here, and here's the delta matrix, which are the displacements of each joint.